horizontal and vertical lines, finding slope from a graph, finding slope between 2 points, and relating slope to a real world situation, because it seemed like some of you needed help remembering that last week. But I think we've done some review, so I don't think this is going to be totally new for you, like it's slowly coming back. So just graphing horizontal and vertical lines, it says horizontal lines have a slope of 0, vertical lines have a slope that's undefined. So if you were going to graph this graph part A, if you wanted to rewrite this, you really have 0x plus 2. See how you have a slope of 0? So if you start at 2 and you rise 0, you've got a horizontal line at 2. So just knowing that all the points on this graph, anywhere I look, this is the point 3, 2, or 5, 2. The y value is always 2. On part B, the y value is always 0. So y equals 0, it's kind of hard to see, but it's a horizontal line at 0. So these are a little bit different than slope-intercept form because there's no x, right? Y equals mx plus b. And then example C, now you've got a vertical line. There's no y equals anymore. This is the only time when there's no y equals. So all the x values are 5, means that this is a vertical line at 5. And if you wrote down these coordinates, this is 5, 1. This is 5, 4. 5, -3. All the x values are 5 on that line. So just knowing how to graph horizontal and vertical lines. When we graph systems of equations, you might have to graph one of these and figure out, where it intersects another diagonal line, right? So just finding the intersection point. All right, so now here are just some lines. All I want you to do is tell me the slope of the line. So if I start at one point and I do my rise over my run, have you heard of slope triangles before? So this one is rising 3, 1, 2, 3, and it's running 4, and it's a positive slope because it's rising from left to right. So the slope of this line is positive 3/4. They don't even care if you write the equation. They just want the slope for this practice. All right, so now on B, I'm going to start here. This time I'm dropping 1, 2, 3, 4, right? I'm going down 4 and over 1, 2, 3, 4, 5. So negative 4/5 would be the slope this time. And I'd like you to try C on your own, and we'll just compare our answer in a minute here. See if you can find the slope for C. You might have to pick 2 points, so I would pick maybe this point. I guess this one's okay. Anything where it intersects a grid line, I think is best. So if you pick those 2, I think it's easier to see the slope. So down 1 over 2, right? Negative 1/2. So that's slope graphically from a line. Anyone need help on that? Make sense? Okay, and then what if I just give you 2 points, but I don't have them graphed? You could graph them, and you could find the rise over the run the same way using a slope triangle. So if you ever need a sheet of graph paper to do that, that's fine. At least you're understanding what slope is. But there's a formula. You subtract your y values, and then you subtract your x values. So I just happen to always pick this as my 2's, my y1 and my x2 and my y2. You could do it in any order as long as you are consistent. So I just always go to the second set of points and I grab this 4 minus 5. So for me, I would do 4 minus 5, those are the y values, over negative 2 is my x value, minus 0. And now I'm just going to reduce that fraction. So I get negative 1 in the numerator, negative 2 in the denominator, and that simplifies negative divided by negative to actually positive 1/2. So what I mean by if you need a slope triangle, use it, right? If you needed to plot out 0, 5 and negative 2, 4, right? And then figure out what the rise and the run is, you're still doing slope, You're just thinking more graphically than algebraically. I don't care which way you think, whatever way makes more sense to you. Sometimes with big numbers, it might be a pain, like 20, 81. That might be a tough one to do graphically. But so if I did -1 minus 3, so -1 minus 3 over 5 minus 8. So that gives me -4 over -3. So again, a negative divided by a negative is positive 4/3 slope. And then an interesting thing happens on part C. I get 5 minus 5 in my numerator. And then -3 minus 6. So that gives me 0 over -9. I can't leave my answer like that. 0 divided by anything is always 0. Right, so hey, glad you're feeling better. I think they said you already ate, but so I don't know if you want that. You can just put it on another desk and I think Jazzy said she would drink your chocolate milk though. If you still want the chocolate milk. But feel free to just stick it on that desk if you don't want it. So Aiden, right? Aiden said undefined. If you have 0 in the denominator, it's undefined. He's right. How can I remember that? So if I forget, you can actually type it in on your calculator. So if I do 0 divided by -9, see how the calculator tells me it's 0? Let's say I did -9 divided by 0 on the bottom. My calculator is going to give me the error message for dividing by 0. So when in doubt, maybe try it on the calculator, but I think of it as if the fraction has nothing to sit on, right? I have to sit on something, right? It's unsteady if 0 is on the bottom. And then 0 divided by anything is still 0. Okay.
So this would instead be like y equals 5, right? They both have y and they don't know any distance on the line.
Right, so the slope is 0.
Right.
Right, so yeah, it's a horizontal line at 5, but the slope was 0. If it had been undefined, it would have been a vertical line.
Okay.
So yeah, if you think about it graphically, that'll tell you the slope as well. Okay, part 4, and then we're going to take a quick walk to get a stretch break, even though, Brady, if you want to stay, and we kind of just did a warm-up in this page. We're on 112 right now. Just relating slope to a real-world situation. So a climber's on a hike. After 2 hours, he's at an altitude of 400 feet, and after 6 hours, he's at an altitude of 700 feet. What's his average rate of change? So we want to figure out how many feet per hour. So I always think of what am I trying to figure out? How fast is he walking? His altitude feet per hour. So how many feet has he gone up? He's gone from 400 to 700, right? So he's increased by 300 feet. How many hours did it take? From 2 hours to 6 hours, so 4. So 300 divided by 4 is going to get you his average rate per hour. So it sounds like an average of 75 feet per hour. To me, rate of change makes more sense in real world situations why we would need it. And if you knew the average speed, maybe if someone got lost, you could figure out, oh, well, if they were hiking for 2 more hours, they're probably in this range of, location. All right, the scuba diver is 30 feet below the surface at 10 seconds after he entered the water, and then 100 feet below after 40 seconds. What is the scuba diver's rate of change? So they went from 30 feet to 100 feet, right? So we could think of that as they're going down negative 70 feet in the water, right? As you're going down in the water, it'd be negative maybe. So negative 70 feet. And how many seconds was that? From 10 seconds to 40 seconds would have been 30 seconds change, right? So it's going to give you how many feet they went down per second. And does anyone in here scuba dive? Did anyone have Franco last year? He was a big scuba diver, right? And there's some rate that you got to go slow enough so that you don't get something. Okay, yeah. You want to ascend and descend at a certain rate. I think he said he was like cleaning milfoil off the bottom of the lake or something. Negative 2 1/3 feet per second. So I don't know, he would be a good one to ask. I should ask him what the actual safe rate of change is to not get the whatever compression.
If it's just like, if it's saying what, how many feet is going down per second,
Yeah.
it wouldn't be negative.
Yeah, if you want to say that that's positive, that makes sense to me. How many feet per second he's going down? I was thinking of direction, but yeah, that's fine. Why don't you try C and D? See if you can figure out those rates of change to wrap this up, and I'll put the answers up in just a minute to check them. So think about the rocket. They want the change in miles per second, it says. And then the weight change would be pounds per year, right? So when you're thinking of what to divide by what, the unit helps you figure out what to do for the person who needs it. Okay, so yeah, a total of 120 seconds. So 4 divided by 120. See, it's okay to make mistakes. I make mistakes. At least you corrected me so that I didn't confuse you. So miles per second, right? So to figure out how many miles per minute, wouldn't we have to multiply that times 60 seconds in 1 minute? Have you guys looked in science at unit conversions? So 0.33 miles per second. So a unit conversion is when you multiply an equivalency over here, that there are 60 seconds in 1 minute, so that your second units cancel each other out. Oh, just leave it right there for me. Thank you so much. So it's really just multiply that number times 60. So 2. Did it come out to 2? Yep, so 2, what is our new rate in miles per minute? 2 miles per minute sounds a little bit better. I can kind of understand how far that is. Question? Because you just skipped finding this one altogether, right? Yeah, I mean, the question says, what is the rocket's rate of change in miles per second and also miles per minute? So they wanted you to calculate both of them, but you're right. If you get to this one in an easier way, that's fine. Yeah, that's fine. You're understanding rate of change, so that's fine. Okay, and then what was this one? They changed by, is that 45 pounds? So 45 pounds divided by 34 years came out to how much? 1.3? That's not that bad. 1.3 pounds per year. I mean, hopefully you're not gaining 1.3 pounds per year for every single year because you don't want to keep that up consistently. But 1.3 pounds per year if you rounded. I just did 45 divided by 34 and got that. Oops, that. Rounded to 1.3. Kind of makes sense. So after the performance task, or for homework, I'd like you to, these are very similar to what we just did, the guided practice and using slope. All right, so you're going to do 120